So let's pick up where we left off. We're still talking about, we're still introducing quadratics. We're still getting used to what a quadratic is, what it looks like, how to find the parts of it, all that good stuff. I want to talk about graphing first. Basic steps you have to follow. Number one, you have to find and sketch the line of symmetry, which if you will remember is this equation, x equals the opposite of b over 2a. So we're going to take this equation right here and we're going to find the axis of symmetry. The opposite of b is going to be 2. And then 2a is going to be 2 times negative 1/2. Well, if I multiply those together, there goes my pen acting funny again. I end up with 2 times negative 1/2 is negative 1, which just gives me negative 2. So my line of symmetry is going to be at x equals negative 2, which is right here. And so I'm sketching really poorly, but it's this line right here on my graph. Then I have to find and plot the vertex. Well, the x value of my vertex is exactly the same as my line of symmetry because my line of symmetry crosses right through the middle. The vertex is smack in the middle. And so the x coordinate of the vertex is always going to be the same as the line of symmetry. That's why we find it first. Since I know the x coordinate, if I want to find the y coordinate, I can just plug it into here and find out what y equals. So I'm going to plug in negative 2 into this. So I end up with negative 1/2 times negative 2 squared minus 2 times negative 2 plus 1. Well, negative 2 squared is 4, and then 4 times negative 1/2 goes right back to negative 2. And then negative 2 times negative 2 is 4, and then plus 1, I'll just do the math. Negative 2 plus 4 is 2, plus 1 gives me 3. So my vertex should be at negative 2, 3. Change my color so that this shows up really well. So at negative 2, 3 is my vertex. Now I have to make a table of values using two values of x that are larger than the x value of the vertex and then plot them on the graph. I would recommend not going too much larger than the x value of the vertex. In this case, the x value of my vertex is negative 2. So two numbers that are larger than that, let's go 0 and 1. They're both bigger than negative 2. They're both going to be really easy to work with. Then if I want to find the y coordinates for these, I do the same thing I did here and I plug these x values into my equation. So let's do the 0 first. I have negative 1/2 times 0 squared minus 2 times 0 plus 1. Well, this is going to be 0, this is going to be 0, and that's going to be 1. Well, that just gives me 1. So y, when x is 0, is 1. Then if x is 1, I plug it into here. So I have negative 1/2 times 1 squared minus 2 times 1 plus 1. Well, 1 squared is 1 times negative 1/2 is negative 1/2 minus 2 plus 1. Well, since order doesn't really matter here, negative 2 plus 1 is negative 2, and then negative 2 and negative 1/2. Yes, I'm going to use my calculator. This comes out to negative 1.5, and I'm just going to write it as negative 1.5. That will be easier to graph. So these now are points that go on my graph. So I'm going to scroll back up so you can see my pretty picture here. Switch back to the red so it shows up. The first point I want to plot is 0 and 1. So I have 0 and 1. And then the next one is 1 and negative 1.5. This gives me half of my parabola. It's kind of an ugly thing, but if you use symmetry, because that's the next step that I have, it says use symmetry, plot two other points on the curve. Since I know that this line, the purple one I drew, cuts this directly in half, I can just use symmetry and what I know about, cutting things in half to draw the rest of it. So if this point is right here, then there is a similar point on the other side over here so that I have symmetry. And then this point is right here, and so when I connect them, I end up with a parabola. And so this is the graph of that function, and this is how you graph it. Find the line of symmetry, find the vertex, and then pick two other points on the graph, find them and plot them, and then use symmetry to find the other two. You have your quadratic. The good news is you won't have to graph by hand very often, but you do need this to complete your homework for tonight. So, moving on, we're now going to introduce, I I do apologize. We are going to introduce Quadratics Day 2. So now we're going to move on to Day 2 of Quadratics, and it's more of the same kind of stuff. We're going to just talk about quadratics and their parts and their pieces and the things we need to know. So first we're going to do multiple representations, which you have done with linear functions. Now we're going to do these same things with quadratic functions. So here is the function y minus 2x squared equals 8x minus 3. The first thing that you need to know is this right here is standard form of a quadratic function. It has to be y equals, and then it's ax squared plus bx plus c. I can't graph anything unless it is in standard form, unless it is written as y equals. So the first thing I have to do with this is get the y all by itself. Well, if I want y all by itself, I've got to get rid of this minus 2x squared, so I'm going to add 2x squared to both sides. And then I'm just going to make sure I write it in the correct order so that it looks like this. So I end up with y equals 2x squared comes first plus 8x minus 3. This way I can find my a, b, and c really easy. So I'm going to use this function, and I'm going to come up with a table that goes with this that matches my function. If I know the x values and I want to know the y values, all I have to do is plug these x values into this equation in order to get them. Now I'm going to do the first one with you, and then I'm going to have you pause, and we're going to fill in and have you fill in the rest of it, and you can come back and check just to be sure. This is just going to take way too much time if we do all of these values by hand all at once. So I'm going to plug in -4 into this equation. So you have, and I'm going to write and then I'm going to erase. So I'm going to end up with y equals 2 times -4 squared plus 8 times -4 minus 3. Well, -4 squared is 16, and 16 times 2 is 32. 8 times -4 is -32 minus 3. Well, these cancel, leaving me with -3, so y equals -3. So why don't you take just a break for just a second and then come right back and we'll finish. So, and you can check where your values in this table and make sure that you have the same things that I have. At -3, y is -9. At -2, y is -11. At -1, y is -9 again, so somewhere in between there is going to be my axis of symmetry, and then at 0, y is -3 again. And so you can see it's this pretty little symmetrical thing. So I now have a table, and so I have represented this in multiple ways. I have represented it as a function right here. I've now represented it as a table, and now we're going to represent it as a mapping. You have seen a mapping before, it's just been a while. So I'm going to show you one more time. When you do a mapping, you have these pretty little ovals. Hopefully yours are prettier than mine. This represents x and this represents y. And you list all the values from the table into your mapping, and you put them in order. So I have -4, -3, -2, -1, and 0 for my x's. Then my y's, I have -3. I apologize, we're going to put them in order least to greatest, not, in any mamby-pamby order we want. They're going to go least to greatest. So the smallest one is -11, -9, and -3. And I'm only going to list the -9 and -3 once, because when they repeat, it doesn't matter. With the mapping, I'm going to draw arrows anyway. The -4 meets up with the -3. -3 goes with -9. -2 with -11. -1 with -9. And 0 with -3. That's what my mapping would look like. Now, if I wanted to graph it, I would plot these points onto the graph, and I would connect them so that I had a pretty little graph. So I have -4, -3, -3, 5, 6, 4, 5, 6, 7, 8, 9. And then I have -2, 11. And then I have -1, -9. And I have 0, -3. So I have this pretty little parabola right here that looks just like this. Wasn't a very smooth curve, but you get the idea. So you have the pretty parabola. Now we're going to talk about domain and range real quick. This should be old for you by now, but you can tell by the graph, extends on forever. My domain is going to be -infinity to +infinity, or all real numbers with that pretty funky R you can draw. parabolas are always going to have a domain of all real numbers unless there are endpoints at the ends of that. Now my range goes from negative 11 to positive infinity, or I can say y is greater than or equal to negative 11 because it is all those numbers. Okay, so let's talk about how to use a graph to answer some questions. So you have a graph that represents the relationship between the height in yards and the horizontal distance in yards of a soccer ball after it was kicked. This is what the graph looks like. They ask you to find the following values, and so here's what you know. They're asking you to find f of 7.5, and if you will remember from first semester, we did this stuff, f of x, and it was the same thing as saying y equals, f of x equals. It meant the same thing, and so that's basically what they're saying here. They're saying y equals. They're wanting you to find out what y equals when x is 7.5 because they've replaced the x with 7.5. So if you go over to your graph and you look, this is 5, this is 10, this is 15. So every bold line is going to be 5, which means everything in the middle is 2.5. So this is your 7.5 right here. If x is 7.5 and I go up here to my graph, it touches my graph right here, and if I follow that over to the y-axis, I get that that is going to be 3.5. So f of 7.5, according to my graph, is 3.5. Then they ask again for f of 22.5, which is going to be halfway between 20 and 25, and I do the same thing. If I draw a line up here to meet my graph, it meets my graph right here, and if I go over to where that meets the x-axis or the y-axis, I get that it equals 8. Now the next question is a little different because they say when f of x equals 2, find the value of x. They're basically saying when y equals 2, find x. So now they're asking it a different way. They're saying y equals 2, so they want you to go from the y-axis to the graph and then drop down and see, well, that is going to be about 4 because it's not quite 5, but it's pretty close. So we can say that it is about 4. So x is approximately 4. And so that's how you use the graph to answer those questions. If the number is in parentheses, they're giving you x and they want y. If they give you the number outside of parentheses and they ask for the x, that means they've given you y, they want x, you just have to work backwards. Now this next little part, you're being asked to find a quadratic regression, which is going to require that you use your calculator, and I'm going to walk you through it really quick just so you can see it. But then I'm going to, if you have questions about this tomorrow in class, we will go over them. It's a lot like finding a linear regression, which is finding the equation using the calculator, but it's not exactly the same. And so if you have a table of values like we are going to have right here, and I'm going to just fill in these numbers. I'm going to have -2, -1, sorry about that, 0, 1, and 2. And then fill in the rest of this table. I end up with 5, 2, 1, 2, and 5. We want to find what the equation is of this table, and it is quadratic. And I'll show you tomorrow exactly how I know it's quadratic. It's a quick, easy thing we'll do as a warm up at the beginning of class. But I'm going to use my calculator and this table to figure out what the equation is. So here's how this works, and it's just like when we did this before with our calculator. We want to enter those values from the table into our calculator. So we're going to go to Stat and Edit. And we're going to enter those values into our table, and you can see I already have them here, but you want to enter the x values in list 1 and the y values in list 2, and once you have them entered in, you're going to go back to Stat, but this time you want to go over to Calc. And before we would do number 4, linear regression, because we were looking for the equation of a line. Now we're looking for the equation of a quadratic, so we want to do number 5, the quadrag. So you hit number 5, and you would hit enter, and it would pull up this. And so it's telling you that y is equal to ax squared plus bx plus c, which you should recognize now as standard form. And then it tells you a is 1, b is 0, and c is 1. And so that means that my equation is going to be y equals 1x squared plus 0x, which I don't have to write, plus 1. So it's really just y equals x squared plus 1. That is the quadratic regression equation. And we can go over this again tomorrow. You'll probably still have some questions, but there it is. That's how that's going to work. So now let's talk about evaluating quadratic functions. Evaluating quadratic functions is pretty simple. To remember, to evaluate means to solve. Okay, so they're just asking you really to solve these quadratic equations given certain things. So number one, it says, given the quadratic function f of x equals 3x squared plus 2x minus 5, find the dependent variables when the independent variables are negative 3, 0, 1, and 5. And so they're asking you to find something. They are telling you, if you will remember way back first semester, again, dependent are the y values and independent are the x values. So they're saying if x is these four numbers, find out what y equals. So we're just going to plug these numbers in. So I'm going to take these values, I'm going to plug them into my equation. So I'm going to end up, for negative 3, I'm going to plug in negative 3. So I'm going to end up with 3 times negative 3 squared plus 2 times negative 3 minus 5. Well, negative 3 squared is 9, and 9 times 3 is 27, and that's negative 6. And then so it's just doing the math. 27 minus 6 is going to be 21, and 21 minus 5 is going to be 16. So this ends up being 16. And so there's your first value for your problem. There's the first dependent value. And so then you get to repeat it for the 0, 1, and 5. So we'll do it again for the 0. So I will plug in 0. So I have 3 times 0 squared plus 2 times 0 minus 5. I love it when they're zeros because this just makes 0. That makes 0. And that's minus 5. Well, that 0 plus 0 is 0 minus 5 is negative 5. And you repeat this process for the 1 and for the 5 to get the other two numbers. And when you're done, you write them in brackets just like they were written up in our problem. And you write down the other two that you found. Now that is one way to do this. It is not the only way. You can also use your calculator to answer these questions. You can do it the same way. This right here, given the quadratic function f of x equals negative 5x squared plus 2x plus 6, find the dependent or y variables when the independent or x variables are these numbers. And they gave you some pretty big numbers. Now we can plug these in or we can use our calculator. So we're going to use our calculator. So we're going to go back over here and we're going to go to y equals, and we're going to type in that equation that they just gave us, which was negative 5x squared plus 2x plus 6. And instead of actually graphing it and see what it looks like, I'm going to look at the table. So I'm going to go to second graph, and here is the table of all the values. Well, the first thing they asked me to find was when x is negative 31. So I'm just going to scroll up in my table until I get to x is negative 31. And right here I see that when x is negative 31, y is equal to negative 4,861. So my value here is negative 4,861. And then I will repeat this for when x is negative 9. And so I will scroll back down to where negative 9 is, which is right here, and I see that y is negative 417. So I get negative 417. And you repeat that, you keep going until you do the 5, and then you do the 22, you write down the numbers, and you have that just like before. And so it's the same kind of deal, just like the last one. And we write them down. So you can either plug in the numbers, or you can use your calculator to find them. Now, using the calculator only works if they are giving you x but ask for y. If they give you y but ask for x, we have to treat that completely differently, and you should not see any of those on your assignment for this because we don't know how to do that yet. So let's do the last one. Given the quadratic equation f of x equals 2x squared minus 3x plus 1, find these four values. They're saying the same thing. Find f of negative 32. So we're going to plug negative 32 in and find out what it equals. So find f of negative 32. I'm going to do 2 times negative 32 squared minus 3 times negative 32 plus 1. And I'm going to pull out my calculator. Negative 32 squared is 1,024 times 2. This becomes 2,048. A negative and a negative here makes a positive, and 3 times 32 is 96 plus 1. And then I just add those all up. And I get that f of negative 32 is equal to 2,145. Now you could also use your calculator just like before because I know what x equals. So I can plug this in and scroll up to where x is negative 32 and then write down the number. And then you repeat that process for the other three, do the same thing. Plug them in or go find them on your calculator. So that is the rest of quadratics. We will talk tomorrow about the difference between linear and quadratic. It'll be a quick little 3 to 5 minute warm up, and then I will turn you loose on your assignment. I will see you then. Have a good rest of your evening.